Okay, before we start lesson 45 on difference of squares theorem, I just want to mention that there's another way to find x in this problem on lesson 44. You don't have to have trig functions to find x because you already know the Pythagorean theorem, which tells me that the sum of the squares of the legs of a right triangle add up to the square of the hypotenuse. You could have just said x squared plus 6 squared is equal to 7 squared. So you would have x squared is equal to 49 minus 36, and that is going to be 13. So that would mean that x squared is 13, so x would be the square root of 13. Now, where I'm going to go from here is to say that if x squared equals 13, then x would have to be the square root of 13 because the square root of 13 squared is 13. But isn't there also another number that you can square to get 13? There is, and it would be negative square root of 13. If you square this, you also get 13. So when I solved for x in that equation, why didn't I include negative square root of 13 as a possibility for the side of the triangle x? Well, that's because this is a length, and lengths cannot be negative. So negative square root of 13, that number, is not going to be a choice for x. When we do this kind of problem, we haven't really been thinking about the possibility of there being two different possible answers for that problem, for that question, because we've only been dealing with positive values because we're talking about lengths. But if you have just a regular everyday equation, then you have to start thinking about the fact that an x squared equals something actually has two solutions, a positive solution and a negative solution. Okay, so, and you may have already seen this when you've been doing solving by factoring. If you have this equation, 4x squared equals 9, and you want to solve that equation, what does it mean to solve an equation? It means find out what x could be so that that equation would be a true statement. Are there numbers that you could plug in here for x that when you multiply it out, you square the number, you multiply it by 4, you get 9? How many of those solutions are there? There are 2, because we know that the highest power on x in our equation tells us how many solutions there will be. When I solve by factoring, the first thing I do is get everything on one side and have it all equal 0. So I'm going to subtract 9 on both sides, and I'll have 4x squared minus 9 equals 0. I should notice that on the left side, I have a difference of squares. This 4x squared can be written as 2x squared, and 9 can be written as 3 squared. When I have something squared minus something else squared, I'm always going to have a product of conjugates, first thing plus the second thing, times the first thing minus the second thing. So I've factored it, and now I know that if I multiply two factors together and it equals 0, one of them has to be 0. So either 2x plus 3 is 0, or 2x minus 3 is 0. If I solve for x here, I've got 2x equals negative 3, so x is negative 3 halves. And over here, I've got 2x equals 3, and x equals positive 3 halves. So when I solve by factoring, I get two solutions, which is what I should expect because the highest power on x is 2, and they are opposites, in this case, negative 3 halves and positive 3 halves. Now, if I were to solve this same equation, 4x squared equals 9, by taking the square root on both sides of the equation, that's another way, that's another thing you are allowed to do, is to take the square root on both sides of an equation like this. If I take the square root of 4x squared, I'm going to get 2x. And if I take the square root of 9, I'm going to get 3. And if I divide by 2 on both sides, I get x equals 3 halves. Now, I only got one solution by doing it that way, and that's not okay because I want to know all the solutions. So what the difference of two squares theorem tells me, which we're going to look at right now, is that when I see this sign, okay, that actual sign appears somewhere, that little check mark with a line going above it. That is called a square root sign. If I see that particular sign in writing, in print, it's a problem that already, is there on the page, and it has something like square root of 9. There's only one answer to that, and that's 3. But that is just because that's what that particular sign is used for. It's really only used to tell you the positive square root of a number, because 9 has 2 square roots. 3 times 3 is 9, and -3 times -3 is also 9. So there are 2 square roots. Every number has 2 square roots. It has a positive one and a negative one. But what if we see this sign, the radical sign, the mathematical notation, the understanding of that notation is I'm talking about the positive square root of 9. However, if I'm solving a problem like this, if I take the square root on both sides of the equation, I need to know all the possible square roots that I'm dealing with here. So when I say square root of 9, now I need to include both square roots, the positive one and the negative one. So to do that, I put a little plus or minus there and a little plus or minus there to show me that there are 2 possible solutions to that equation, positive 3/2 and negative 3/2. We do this whenever we take the square root on both sides of an equation to solve an equation. But anytime you see this sign just sitting out there in a problem, it only means the positive square root of 9. So just try to wrap your head around that. So if we have a problem like this, well, first of all, we'll read the difference of two squares theorem. It says if p and q are real numbers, and if p squared equals q squared, then p equals q, or p could be negative q. So the upshot is, if I have a problem like this, x plus 17 quantity squared equals 2, and I want to solve for x, I'm going to have to take the square root on both sides of the equation to make that square go away. But when I do it, I have to put a plus or minus over here in front of that square root of 2, because 2 has 2 square roots, positive square root of 2 and negative square root of 2. So when I do the square root sign on the left, that makes the 2, the square, go away, and I will just have x plus 17. And on this side, I will have plus or minus square root of 2. And then to solve for x, I'll subtract 17 on both sides, and I'll have negative 17 plus or minus the square root of 2. So this equation has 2 solutions for x. X could be negative 17 plus the square root of 2, or it could be negative 17 minus the square root of 2. Those are the 2 solutions to this equation. And this is what this means. 2 different values. Negative 17 plus the square root of 2 is a solution to this equation. Watch, I'll show you. All right, so x plus 17, quantity squared, is equal to 2. If we look for the solutions, we found the solutions. We will plug this in for x first and see if it works. Negative 17 plus the square root of 2 plus 17, quantity squared, equals 2. That is true because the 17s go away and I just have square root of 2 squared, and that does equal 2. If I put in negative 17 minus the square root of 2 into the equation, I will have negative 17 minus the square root of 2 plus 17, quantity squared, equals 2. The 17s will still cancel out, and I'll have the negative square root of 2 squared equals 2, and that is also true. So here's another one. If we want to solve this, we're just going to take the square root on both sides, and that'll make that square go away. So I'll take the square root over here, and I'll take the square root over here, but I will put a plus or minus sign there when I do it. So on the left side, that square goes away, and I just end up with x plus 2/5. And over here, I have plus or minus the square root of 3. Subtract 2/5 on both sides, and you have x equals negative 2/5 plus or minus the square root of 3. Okay, so that's all there is in lesson 45, and 46 is just more of these problems that involve these kinds of square roots. So we want to simplify this. It's not difficult. We've done both of these kinds of things before. We just haven't mixed this kind of radicals with fractions, rationalizing the denominators, and other kinds of radicals. We just haven't mixed it all together, but it's the same stuff is just all at the same time now. So we're going to try to write small because we've got a lot to do here. So 3 times the square root of 2/7 is the same thing as 3 times the square root of 2 over the square root of 7. 5 times the square root of 7 over the square root of 7 over 2 is 5 times the square root of 7 over the square root of 2. And then 3 square root of 56, I'm going to change that into 3 square root of the prime factorization, 2 times 2 times 2 times 7. All right, this first fraction, I'm going to have to multiply the top and the bottom by the square root of 7 because I cannot have a square root in the denominator. That's not okay. So I'm rationalizing this first fraction. So it's going to be 3 times the square root of 14 over 7. The second fraction, I'm also going to have to rationalize it because it has a square root of 2 in the denominator, and that's not okay. So I have to multiply the top and the bottom by the square root of 2, and I will end up with 5 square root of 14 over 2. Now I've got this 3 times the square root of 2 times square root of 2 times square root of 2 times square root of 7. 2 of those, so 3 times the square root of 2 times the square root of 2, those two square roots of 2 multiply together to give me 2. So 3 times 2, and then I'm left with 2 times 7 still in the radical, which is 14. So I have all these square root of 14s, and so since I can add these things together, I'm going to need to get a common denominator and add up all those square root of 14s. Before I do that, I'm going to go ahead and change this 3 times 2 here to 6. All right, so common denominator here is going to be 14. 7 and 2, least common multiple is 14. So I need to multiply the top and bottom of this first fraction by 2 over 2. And I need to multiply the top and bottom of the second fraction by 7 over 7. So I'm going to move that plus sign a little bit. 7 over 7. Multiply this by 14 over 14. So we've got a common denominator. We've got 6 square root of 14 over 14 minus 35 square root of 14 over 14 plus 84 square root of 14 over 14. So it's all over 14. And if I add that up, I'm going to have 55 square root of 14 over 14. All right. So here we have a little bit of a different kind of radical problem where we have a radical inside of a radical. So what we do when we have this kind of situation is we use fractional exponents. We don't want those little radicals all over the place. It's confusing. So what we're going to do is change all the radicals into fractional exponents. Remember, if you take the cube root of a number, it's the same as raising that number to 1/3, the 1/3 power. So the first thing I'm going to do is change the outside radical to a fractional exponent. So I'm taking the cube root of all this stuff right here. That's all under the cube root sign. So instead of saying the cube root of that, I'm going to say 3 square root of 3 all raised to the 1/3 power. It's just another way to write the cube root of 3 square root of 3. All right, now, since I've done that, I am going to change that square root of 3 there. I'm going to change that to 3 to the 1/2 because that's another way to write square root. So I'm changing that. So 3, that was already there. And then I've got 3 to the 1/2 for that square root of 3. And then I've got the 1/3 for the exponent on the outside. Now I have two like bases being multiplied together so I can add their exponents. So this is 3 to the first times 3 to the 1/2. So that is going to be 3 to the 2/2 plus 1/2 is 3/2. And then I still have this 1/3 on the outside. So now I've got a power raised to another power. And the rule is that you can multiply those exponents. So that's going to be 3 raised to the 3/2 times 1/3, which is just 3 to the 1/2 power, which is just the square root of 3. Here's another one where we have just a lot of things under square roots and cube roots and so on. And it's easier to simplify this if we just change all those things to fractional exponents, all those square roots and cube roots. So we're going to rewrite the square root of x cubed y squared to x cubed y squared raised to the 1/2 power. So that's that first thing there. Another way to write square root is to raise something to the 1/2 power. All right, now I'm going to look at that cube root of xy. Another way to write that is xy raised to the 1/3 power. So now we've gotten rid of all those radical signs, and we can start combining these using the rules for exponents. So in our first set of parentheses, we have 2 powers that are raised to another power. So I can multiply 1/2 by the exponents of those factors. So that is equal to x to the 3/2, y to the 2/2, raise a power to another power, multiply the exponents. And then here I've got x to the first, y to the first, raised to the 1/3 power. So again, I can multiply those exponents. X to the first raised to the 1/3 power is just x to the 1/3. And then y, raising it to the 1/3 power, is that. I have my like bases. If I multiply like bases, I can add the exponents. So x to the 3/2 plus the 1/3. And then y, I've got y to the 2/2, which is 1, plus 1/3. Multiply like bases, add the exponents. So 3/2 is the same thing as 9/6. So x to the 9/6 plus 2/6. 1/3 is 2/6. And then y to the 3/3 plus 1/3. And that's going to give me x to the 11/6 and y to the 4/3. Again, we're going to change all these radicals to fractional exponents. So we've got x to the 5th, y cubed, raised to the 1/3 power. And then we have x, y to the 5th, raised to the 1/4 power. Now we have a power raised to another power. We can multiply the exponents. So x raised to the 5 times 1/3, which is 5/3. Y raised to the 3 times 1/3, which is 1. Then we have x to the 1/4 and y to the 5/4. Now we have like bases. We have x to the 5/3 and x to the 1/4, so we can add those exponents. And then y to the first and y to the 5/4. If I multiply those like bases, I can add the exponents. So the common denominator here, 5/3 plus 1/4, the common denominator is going to be 12. So that's 20/12 plus 3/12. And y, that's going to be 4/4 plus 5/4. So that's going to be x to the 23/12 and y to the 9/4.